So our next topic of discussion would be refraction through prism. In this we'll be considering only triangular prisms. That means the prism would look like this. This is an example of a triangular prism. So till now we had discussed refraction at plane surfaces. Now we will move on to refraction through prisms. The angle between the two surfaces AB and AC in this prism is known as the angle of the prism. Now in this case, as you can see that since AB is not parallel to AC, that means what? Till now we had discussed that if there is a rectangular glass slab and there is a refraction occurring, then what happens is the emergent ray, this is the incident ray, the emergent ray comes out parallel as the incident ray and there is only a lateral displacement. But in this case, as AB and AC are not parallel, that means that the incident ray won't be parallel to the emergent ray, which finally means that since the incident ray is not parallel to the emergent ray, there is a deviation occurring. So these are the main points. The first point is that the angle between AB and AC is known as the angle of prism, angle A. AB is not parallel to AC. That means what? The incident ray is not parallel to the emergent ray. That means there is a deviation occurring. Let's see how that looks. Let's say an incident ray strikes the prism at this place. Now at this surface there is a refraction occurring, so it gets refracted. Now there is a second refraction occurring at this surface, right? And this is the light ray moves from the denser medium to the rarer medium. So this is my incident ray with an angle of incidence I, and this is my emergent ray with angle of emergence E. There are two refractions occurring here. Let me assume that the first angle of refraction is R1 and the second angle of refraction is R2. To find the angle of deviation, what we need to do? To find the angle of deviation, we need to see how much the incident ray we need to turn to make it as the emergent ray. For example, in this case, this is the incident ray, I extend it, and this is my emergent ray, right? I extend both. Now you see this angle, I need to turn the incident ray by this angle to find the emergent ray. So this angle is my angle of deviation delta. Okay. Now finally, when we move on to find how to find delta, let's see what's the relation between the first refractive angle R1, the second refraction angle R2, and the angle of prism A. To find that, let's take this triangle, the upper triangle, this one. This angle is R1 and this is the normal. So what is this angle? This angle is 90 minus R1. Similarly here, this angle is R2, this is the normal. So this angle is what? 90 minus R2. Now in this triangle, this is 90 minus R1, this is 90 minus R2, and this is angle A. The sum of the three angles should be 180 degree. So 90 minus R1 plus 90 minus R2 plus A is 180 degree. That means what? Angle A is equal to R1 plus R2, right? Okay. So this is the relation between the angle of prism and the two refraction angles. Now let's move on to find what is the deviation occurring in a prism. Now before we do that, let's first recall what deviation is. You know that in case of reflection, if this is my incident ray, this is my reflected ray, my deviation occurring is this amount, which is equal to pi minus 2i. Okay. Now in case of refraction, what happens? In case of refraction, there is an incident ray which strikes the surface, and depending upon which medium is denser and which medium is rarer, the light ray may move towards the normal or it may move away from the normal. So it may move towards the normal or it may move away from the normal. Okay. So this is my angle I, and if I extend this, if there was no surface, then the incident ray would have just passed like this. This is my refracted ray. So what is the deviation in this case? The deviation in this case is I minus R. Okay, because this is the deviation. Now I put a mod sign here because I don't know which is greater and which is smaller. And angle of deviation is always positive because it measures the difference between the incident ray and the refracted ray, or in other terms, it measures how much angle I need to turn the incident ray to make it the refracted ray. Okay. Now in this case, there are two refractions occurring. One is this and one is this. Right? So, my total deviation delta is equal to the deviation occurring in the first refraction plus the deviation occurring in the second refraction. The deviation occurring in the first refraction is I minus R1. I can remove the mod sign because I know that I is greater than R1 because angle I lies in the rarer medium. Similarly, in this case, which is greater angle? Angle E will be larger than angle R2 because angle E is in the rarer medium. So I'll write this as E minus R2. Now this I can write as I plus E minus R1 plus R2. And what is R1 plus R2? We know that angle of prism is equal to R1 plus R2. So I can write the deviation as 1 I plus E minus A. Okay. Now, let's solve this. What is angle I? Angle I is the angle of incidence, right? What is angle E? Angle E, to find angle E, I'll use the Snell's law. If I apply the Snell's law at this refraction point, I know that mu into sine of R2 is equal to, the mu here is 1 because this medium is air. This is equal to sine of E. That means E is equal to sine inverse mu sine R2. Right? Okay. So let's replace that.